Hello everyone, welcome to my channel. I'm Miga and today we'll be talking about how to assign R and S configuration to a chiral center. So first and foremost, let's make sure that our molecule is chiral. So that means we at least have one carbon that is attached to 4 different groups because we can only assign R and S configuration to a chiral center. So let's locate the chiral center. So this is the line ball structure. We agree that each of those corners represent a carbon, right? So if I can show all the group so that we can see, let's look for the carbon attached to 4 different groups. For example, at this location here, a carbon is attached to a bunch of hydrogen, right? So we have 1 hydrogen, 2 hydrogen, 3 hydrogen, and 1 CH2. So we can say that they are not 4 different groups because here we have 3 hydrogen, they're the same. So not a chiral center. Here at this location, our carbon is attached to 1 group, 2 group, 3, 4, but these 2 groups are the same, right? So this is also not a chiral center. And we can see that here too, it's not a chiral center. But at this location, we can see our carbon is attached to 1 chlorine, which is different from an hydrogen, which is different from the CH3 group here, which is also different from that big group. So we can see that we have 4 different groups. So this is the chiral center. And also, we can agree that this one is not a chiral center, right? Because our carbon is attached to 3 hydrogen and 1 big bulky group, not 4 different groups. Chiral center, we need 4 different groups, okay? Groups. All right, so in our molecule here, we only have 1 chiral center, and this is this one here. Now, let's assign the R and S configuration. After locating your chiral center, in this case, we only have 1, we're gonna assign priority to the 4 groups that are directly connected to the chiral center. In other words, we're gonna rank those groups from 1 to because remember we have 4 different groups, 1, 2, 3, and of course the hydrogen that we know is there, right? The 4th group, from 1 to 4, which one is the most to the least important, right? So to do that, we're gonna use this small part of the periodic table. Okay, so now the trend goes that as you move across a period, right, like a row of the periodic table, there's an increase in atomic number, so the priority also increases. So that means fluorine, anything F, fluorine will be more important than hydrogen or carbon. And also, as you move down a group or a family or a column of the periodic table, priority also increases. So that means the iodide, for example, will also always be more important than either hydrogen, phosphorus, sulfur, etc. Okay, so that means the higher the atomic number, the more important, the higher the priority. So let's use this information to assign priority to the 4 groups that are directly connected to our chiral center. So what are the groups that are connected to our chiral center? We agree that there's a chlorine, right? A carbon attached to 2 hydrogen, okay? A carbon attached to 3 hydrogen on the right. And remember, carbon can do 4 bonds. If a carbon, a corner, for example, here at this location here, if there's no charge and you only see 3 lines connected to it, that means the one that they are not showing is hydrogen, okay? And here at this location, since the professor is telling me that the chlorine is on a wedge, I can assume that the hydrogen that is not shown is on the other one, the other configuration. It's on the dash, okay? So now that we identified the 4 groups connected to the chiral center, let's now assign the priorities to them, right? Based on this table here. So let's see which one is the least, or let's say which one is the most important if it's gonna be easier for you. So let's identify the most important group here. So we're comparing, let me put this in another color. We're comparing chlorine against hydrogen against a carbon and another carbon, okay? So which one is the most important here? So we have hydrogen group, no, hydrogen group, a chlorine, all right, and two carbon, so carbon. So we know here chlorine has the highest priority because it's donor, right? So we're gonna say chlorine will be the first priority. Now, what else do we have left? We have hydrogen against two carbon. Hydrogen against two carbon. We know here that hydrogen has the least priority. So we're gonna assign group 4 to it. And now we're gonna be comparing the carbon on the right, on the left to the carbon on the right. So let me remove some color, right, to make it simpler. Okay, let me zoom in a little. So let's see how we can break the tie. First, I'm gonna list every group each carbon is attached to. So let's do this. On the left here in green, our carbon is attached to one carbon and two hydrogen, right? We agree that there was two hydrogen here that I showed earlier, okay? This carbon here, this purple carbon is attached to three hydrogen. Remember, there's three hydrogen here I showed earlier, okay? Now let's compare between them to see which one is the most important. If we analyze each group that they are attached to, we can see that we broke the tie because this carbon here is at least attached to another carbon as opposed to the purple carbon that is attached to three hydrogen. So we know that this one will have the second priority and this one the third priority. Okay? Now that we have our priorities, now we need to take a pause and see how they are arranged. There's three cases that we need to be aware of. The first case is the one that we've been solving so far, is when the first priority is on a wedge and the fourth priority is on a dash. What do I mean by that? Let's take a look at this. The first priority is on this dark, configuration, like on a wedge, right? And the fourth on the dash. I like to call this the straightforward configuration. Why? Because then you can quickly proceed to determine if it's R and S. Oh, by the way, what does that mean, R and S? R means that you're gonna go in the clockwise direction, and S configuration means we're gonna go in a counterclockwise direction. Let's take a look at this. Once you see that number 1 is on a wedge, number 4 is on a dash, then we can ignore the fourth priority. That's why I put it in gray here, and focus on the first, the second, and third priority. And now let's do the motion, the R or S motion, to determine what we have here. We can do the motion 1 to 2 to 3. We'll go in counterclockwise. Let's compare it with what we had at the bottom. We can see that here, this chiral center here is S. Okay? But this one is the simplest, the easiest, is straightforward. But sometimes our first priority is not always on the wedge and the fourth is not always on the dash. The second common case you can be asked you can see on your exam is that the first priority is the one that is on a dash, while the fourth priority is on a wedge. Basically the opposite of the first case, right? For example, let's assign priority to this one, and I purposely took another molecule so that we can start practicing together. Let's quickly assign priority to this. You'll see that I have my little table here. Let's move it up a little because we're gonna need it. All right, let's quickly do that. First of all, let's look at our chiral center. Here is the chiral center. We can see this group is different from that group, which is different from this group. And we already know there's an hydrogen that is not shown, right? So this is indeed the chiral center. This is not a chiral center because this carbon here is attached to, yes, one CH3 group is attached to this group. But here, look at, that's only one group. Two oxygen, or you can say it's attached to one oxygen, another oxygen, So no, this is not for different group. This is not a chiral center. So we can ignore this one. And of course, we already know that's not a chiral center. This is not one. So let's focus here, right? Now we have a chiral center. Let's assign the priority. We have a nitrogen versus 2 carbon. And of course, if the professor is not showing you the fourth group, and we know it's a line bond structure, we know the hydrogen will be on a wedge because he already put one priority on a dash. So we can assume that hydrogen that is not shown is on the other configuration, right? In this case, on a wedge. All right, let's assign the priority. I know I said it so many times. I'm gonna assign priority, but there's so many little steps to do. All right, so we're comparing one nitrogen against another hydrogen and 2 carbon. From here, we can say that nitrogen is more important than the 2 carbon and of course the hydrogen. So we're gonna put nitrogen as the first priority and hydrogen as the least priority, so the fourth group, because remember we're comparing 4 groups together, right? Now let's compare between this carbon and that carbon here. What to do that, to break the tie, let's analyze the group each of them are attached to. For example, a carbon on the right here is attached to 3 hydrogen. We already know there's 3 hydrogen here. And notice how I'm not going back to the chiral center. Remember, the chiral center is what we're trying to solve. No, we're moving away from it. Now I'm focusing on the other group this carbon is attached to. It's attached to 3 hydrogen. So hydrogen, hydrogen here. And what about our purple carbon here? We can say that it's attached to 1 oxygen. It's also attached to another oxygen, right? Because you need to consider each bond that is part of the double bond, right? And it's attached to 1 carbon. And do you see how we broke the tie? How for example, this first group here, we already broke the tie right there. So we know here that, okay, we already have our first priority, we already have our fourth priority. So what is left is the second and third priority. Okay? So let's remove some color to make things easier. Okay. Let's remove these. All right. So we have our four priorities, right? A 4 group. Now let's do the motion. But before that, remember what I said? If you have number 1 on a wedge, let me quickly go on the first case. If you have number 1 on a wedge, number 4 on a dash, then you can do your motion 1, 2, 2, 2, 3. Assign it according to this one, right? If it's clockwise, counterclockwise, and move on. However, if you have the inverse, you will do the motion too, but you're gonna have to reverse it after. So what I like to do on the exam, once I realize that here, my first priority is on a dash, and my fourth priority is on a wedge, it's not the ideal case. So I'm gonna have to reverse it, okay? So once I know I'm gonna reverse it, let me zoom out a little so that you can follow what I'm saying. Once I know I'm gonna reverse it, now let's do the motion. 1, 2, 2, 2, 3. So remember what I said, R is clockwise, S is counterclockwise, right? So here I'm noticing that I'm going in a clockwise fashion initially. So yes, so initially it would be R. However, at the end, it's S because I'm going to reverse it. So this chiral center here is S. Okay? The third case we can have is when the priority 1 and or priority 4 are neither on a wedge nor on a dash. Because remember, so far we've seen how our focus were on 1 and 4. We want to make sure that they are at least in the wedges and dashes world, right? But if at least one of them is not in that case, then we're gonna have to do a little bit of work. Let's take this example. So first, let's identify our chiral center. I can see from here that this resemble chiral center because it's attached to 4 different groups. It's attached to 1 hydrogen, which is different from this part of the ring, right? Which is different from that other path of the ring. So we have 2 different paths. So we can say this arm is attached, it's different from that here, right? Two different groups, which is different from the hydrogen, which is the third group, which is different from this fourth here. So we can see we have 4 different groups here. This carbon is attached to 4 different groups. So indeed, it is a chiral center group. So now let's assign the priorities. We already know whenever we see hydrogen, it's gonna have the 4th priority. And what other group are we comparing here? Let's see. Our chiral center or blue chiral center here is attached to 1 carbon, 1 oxygen, and another carbon. So we know that oxygen will have the highest priority if we want to compare, because it's like 1 oxygen against 2 carbon. And now let's focus on each carbon to see what they are, which one has the second and which one would have the third priority. So let's see what group each of them are attached to. For example, I like to put some color so that you know what I'm talking about. Green. Okay. So the green carbon here is attached to 1 carbon, right? And 2 hydrogen. Remember, wherever you don't see any, it's a line bond structure, we can already tell that there's 2 hydrogen here. The professor is not showing us because carbon can make 4 bonds, right? Now the purple carbon is attached to, let's see. Oh, okay. 1 carbon, another carbon, and an hydrogen that is not shown, but we know is there, okay? Because again, it is a line bond structure. We know there's an hydrogen like this, right? Now let's see, did we break the tie? Which one is more important between these 2 carbon? Let's compare the group. Carbon here, we didn't break the tie, but oh, look at this. At this location, purple carbon has the highest priority because at the second group is attached to is a carbon as opposed to an hydrogen for the green carbon. So we can say that this group here will have the second priority and the green one will have the third priority. All right, now that we have all the priorities, let's clean it up a little to do our motion and compare, right? Remember to do the motion 1, 2, 2, 2, 3 and move on. Ideally, we want 1 to be on a wedge and 4 to be on a dash. However, here, yes, 4 is on a dash. However, 1 is neither on a wedge nor on a dash. On the contrary, here we have number 2 that is on a wedge. Let's make some space so that we can move our priorities around so that we can have the ideal case we want. Because remember, we want number 1 to be on a wedge, number 4 to be on a dash. So let me rewrite everything. I like to do my work on the side, right? So that everything can be clear. I'm just gonna rewrite the molecule, the chiral center, but only with the group, with the priorities. So we know we have 2 on a wedge, 4 on a dash, and 3 that is on a line structure, on a line, right? One of the tip that I use, one of the trick that I use, because it's explained in many books, it makes sense, and I always get the correct answer, is that after writing your groups, you're allowed to flip groups, but in an even amount of time. So that, what do I mean by that? Let me do one flip. So first flip, okay? Let's do first flip. Remember, the goal is to have number 1 on a wedge and number 4 on a dash. So for now, let's flip these 2 groups so that I'm trying to get as fast as possible to my ideal configuration, right? So I'm gonna copy this. Oh, but I wanna make sure that I actually do the flip, okay? So we're gonna have 1 here and 2 here. That's the first flip. But remember, you have to make sure you do an even amount of time. So that means 2 flip or 4 flip or 6 flip, etc. So I'm gonna do a second flip. But here, because so far I have number 1 on a wedge, number 4 on a dash, that's what I want to at least so that I can do my motion 1, 2, 2, 2, 3 and move on. So I'm gonna leave these alone. I'm gonna flip 3 and 2. So let's copy and paste this again. Oh, that's the danger with copying and pasting. I have to track everything to make sure that I'm not making any mistake. We're not gonna touch 4, we're not gonna touch 1, but this time we're gonna flip 2 and 3. Once you know you flip the second time, right? Then you can do your motion 1, 2, 2, 2, 3. I'm noticing I'm going in a counterclockwise direction. We know it's S. Then I know this Chiral center here, the one here, that's what I'm focused on. It is S. That's the final configuration of this Chiral center. Okay, so a quick recap. I presented 3 cases to you. After assigning the priorities, we know that there's 3 ways that they can be arranged in. The first priority can be on a wedge, the fourth can be on a dash. In that case, it's very straightforward. You can forget about number 4, do 1, 2, 2, 2, 3. You do the motion, and then whatever you get, if you're going, for example, in that case, I was going counterclockwise, I knew that it was S, but if I was going in the opposite motion, it would have been like clockwise, it would have been O. The second case, I like to call it close to home case, where number 1 is the one being on the dash and number 4 is on the wedge. But in this case, you can still do the motion 1, 2, 2, 2, 3. Remember, we don't really care about 4 in that case. That's why usually I like to put it in gray, like I forget about it, right? And then you can do the motion 1, 2, 2, 2, 3. Whatever you get here, for example, here we are going clockwise. We know it was L initially, but it's gonna be the opposite S. You're gonna reverse it because here number 1 wasn't on the wedge and 4 wasn't on the dash. Okay, it was the opposite, so reverse it. And the third case is when neither 1 or 4 or both, they are not on a wedge or on a dash. So the best trick I can say that always work for me is when I use the flipping method so that everything stays straight. I still assign the priorities, but I flip at least 2 times or 4 times or 6 times. But why we want to flip group around 6 times? You're trying to get to the answer, to the ideal configuration with the least amount of flip. Flip group around 2 times. You can flip any group as long as at the end number 4 is on the dash and number 1 is on the wedge. Then you'll be able to do your motion and move on. Okay? And that's all I have for this video. Thank you for watching. Remember, keep practicing until you get comfortable with this material so that we can move on together to the next topic. Thank you for watching and see you on the next one.